Half-life. By the end of this lesson, you should be able to explain half-life, determine half-life from a decay curve, solve problems involving half-life. When an unstable parent nucleus decays, the resulting daughter nucleus is sometimes unstable. If so, the daughter then decays and produces its own daughter, and so on, until a completely stable nucleus is produced. This sequential decay of one nucleus after another is called a radioactive. Elements such as uranium-238 will have to undergo 13 nuclear changes before transforming into a stable nucleus of lead-206. The whole process may take more than 1,000,000 years. However, there are other radioactive decays that take shorter time. 40 atoms of unstable radium-226 atoms undergo alpha decay to transform into the more stable radon-222 atoms. A graph of the number of radium atoms against time for the radioactive decay is plotted. Click on the radium atoms to see how long it takes for half of the radium-226 atoms to transform into radon-222 atoms. How many years does it take to reduce the number of radium atoms from 40 to 20? Click on the radium atoms again to see how long it takes for half of the radium-226 left to transform into radon-222. How many years did it take to reduce the number of radium atoms from 20 to 10? How many years did it take to reduce the number of radium atoms from 10 to 5? What can you say about the time for half the number of radium-226 atoms present to transform into radon-222 atoms? The time for every half the number of radium-226 atoms present to transform into radon-222 atoms is 1,620 years. The time for half the atoms in a radioactive sample present to decay or disintegrate is called the half-life. The symbol for half-life is T-half. Thus, what is the half-life for radium-226? The half-life for the radium-226 nuclide is 1,620 years. The half-life of a particular radioactive nuclide is constant because the decay process is random and a large number of nuclei are involved. The value of the half-life depends on the nature of the radioactive nucleus. Hence, different nuclides have different half-lives. Half-life values ranging from less than a second to billions of years have been reported. Unstable nuclei with short half-lives, for example, boron-1,2 with half-life equals to 20.2 milliseconds, is rarely found to exist naturally. Why? Unstable nuclides undergo alpha decay, beta decay, or gamma decay. These to have different decay rates. What is decay rate? Decay rate is the number of disintegrations per second. The decay rate is also known as the activity or reactivity of a radioactive substance. The SI unit for decay rate is the becquerel, which is 1 disintegration per second. The rate of radioactive decay can be represented by a decay graph. The decay graph is a graph of the number of atoms or reactivity or mass against time. The decay graph shows that the number of atoms or reactivity or mass of a radioactive sample decreases exponentially with time. The half-life of the radioactive material can be calculated from the decay graph. If N0 is the original amount, then half of N0 will be half the amount of undecayed radioactive material left. The time taken for the radioactive material to reduce to half the amount is the half-life for that radioactive material. The amount of the material present is half N0. After going through another half-life, the half of N0 is still undecayed. Thus, the amount of radioactive material left now is half of N0, which is equivalent to a quarter of N0. The general equation to determine the fraction of undecayed substance is 1/2 to the power of n, where n is the number of half-lives starting from 0, 1, 2, and so on. What will be the fraction of undecayed substance after 4 half-lives? The fraction of undecayed substance after 4 half-lives is the number of radioactive emissions in the same amount of time is different for different elements or nuclides. Hence, every radioactive element has its own decay rate. The decay rate is expressed by its half-life. What can you say about the half-life of a radioactive nuclide and its decay rate. A radioactive nuclide with shorter half-life will decay at a faster rate than another radioactive nuclide with longer half-life. When a radioactive material Q decays, the number of atoms is halved after every half-life, while the number of new nuclides increases. Of the undecayed atoms to the original number of atoms, NQ, after 4 half-lives. From the decay series, after 4 half-lives, 1/16 of NQ is still active. What fraction of the original number of atoms, NQ, would have decayed or transformed into other nuclides after 4 half-lives? Since 1/16 of NQ is still active, thus 15/16 NQ has decayed or transformed into other nuclides. Determine the reactivity of material Q after 9,600 days, given that material Q has a half-life of 1,600 days. The following steps may be taken. Step 1. Determine the number of half-lives. Number of half-life in 9,600 days equals 9,600 divided by 1,600 equals 6. Step 2. Draw the decay series for 6 half-lives. Thus, the reactivity of material Q after 9,600 days is 1/64 NQ. The reactivity of material Q can also be determined using 1/2n NQ, where n is the number of half-lives the material went through. A radioactive substance X has an initial reactivity of 240 counts per minute. After 1 hour, the reactivity becomes 30 counts per minute. Determine the half-life for radioactive substance X. The following steps may be taken. Step 1. Determine the number of half-lives by drawing the decay series. Let N0 be the initial reactivity of substance X. The number of half-lives involved in this radioactive decay is Since 3 half-lives is equivalent to 60 minutes, therefore the half-life of radioactive substance X is 20 minutes. Complete the decay graph for a radioactive substance X. Drag and drop the labels to the appropriate place. Determine the half-life for radioactive substance X. The decay of a radioactive substance Q starts at 736 counts per minute and ends at 46 counts per minute in 32 days. Determine the number of half-lives that substance Q went through in 32 days. Key in the reactivity of substance Q in the decay series. Click on the Add Box button to add more boxes. Then, determine the half-life of substance Q. Click on the Check button to check your answer. Substance Q in terms of NQ in the decay series. Fill in the blanks. Click on the Add Box button to add more boxes. Of the radioactive substance Q after 40 days.